Strange theories abound aplenty in the cosmic world, but only a few can match the mystery of the black hole. The paradox became even more complicated when scientists speculated that this iconic interstellar object has a twin called the white hole. But are these elements real? What's the difference between a black hole and a white hole? And what would happen if they both collided? Join us in today's video as we explore and compare white holes with black holes. Without further ado, let's get right into it. What is a white hole? In basic terms, white holes are the theoretical twin sibling of black holes. Scientists define them as a hypothetical cosmic region in space-time that ejects elements but does not accept any form of matter, not even light. This means that elements within a white hole can affect the universe, but no matter what we do, we can never influence what happens within a white hole. This is actually weird because, according to scientists, a white hole has mass, which means it should have some form of gravity that allows them to attract matter, but ironically, that's not the case. What is a black hole? Having defined white holes some moments ago, you wouldn't need to think much to understand what a black hole is. It's the exact opposite of a white hole. According to NASA, a black hole is a place in space where gravity pulls so much that even light cannot get out. You know how you turn on the faucet attached to your sink after brushing your teeth and the water goes down the drain? That's exactly how a black hole is, except the gravitational pull is so strong that even the rapid particles of light traveling at 300,000 kilometers per second get trapped inside. A vacuum cleaner would have been another perfect way to describe this paradox, but black holes don't suck. Rather, anything that gets trapped falls freely as a result of the enormous gravity pull. These thirsty monsters are said to consist of three layers, namely the inner and outer event horizon and the singularity. The event horizon is the boundary or area around the mouth of the black hole, which traps matter. Once a particle crosses this region, it is forever trapped. Meanwhile, the singularity region is the innermost part of the black hole where its mass is concentrated. Interestingly, black holes cannot be seen in the same way that scientists see stars and other celestial elements. The only way to identify them is by observing the radiation they emit. The existence of black holes was first predicted back in 1916 in Albert Einstein's general theory of relativity. However, the concept was without name until American astronomer John Wheeler coined the term black hole in 1967. But still, scientists could not prove that they existed in real life because the only evidence that proved their existence was the theory of relativity published by Einstein. About a century later, they believe they've found enough evidence that confirms that black holes really do exist. But the mysteries around the concept still exist regardless. In 2019, the ever-evolving global network of synchronized radio observatories, known as the Event Horizon Telescope, showcased the first ever picture of a black hole, which was discovered at the center of galaxy M87. During the observation, they noticed a sudden disappearance of particles of light, and this has become the standard way of recognizing black holes. Researchers would spend the next 24 months studying the image and learning more details about it. Scientists hope to discover and explore even more black holes in the future. This would hopefully enable them to unravel some of the mysteries around it. From all indications, we suspect that the Sagittarius A, which is domiciled in the center of our very own Milky Way galaxy, would be the next in line to go under the magnifying glass. It is believed that there are more than 100 million black holes in the Milky Way alone. Scientists sure have a lot of discoveries to make. White hole versus black hole. Now that we've separately defined both elements, it's only fair to see how they compare against each other. Already we've established that nothing can enter a white hole and nothing can escape a black hole. But wait till we tell you the other mysteries that exist about both elements. We are told that black holes feed on the elements around them, and as far as we know, white holes are nothing more but a theory. But think for a second, what if both elements collide? It's hard to really tell what would happen in this scenario, but based on theories presented by scientists, a black hole would ultimately swallow a white hole if they collide. This is because the black hole pulls in space-time while the white hole pushes out space-time. There are two possible outcomes in this theoretical collision. One is that both celestial elements could combine to form a black hole. On the other hand, the pair would become a white hole. But overall, the result you'll get will depend on which element has more mass. That's to say, if the mass of the black hole is more, the collision would give birth to a black hole. However, if the white hole involved is bigger, the outcome would be a white hole. Going back to our sink and faucet analogy earlier, if the amount of water rushing into a sink is small, the drain sucks it. However, if the water is way more than the drainage can handle, the flow of the water reverses. But there's another interesting angle to this whole theory. In the 1970s, a famous theoretical physician, Stephen Hawking, discovered something contradictory about black holes. After extensive research, Hawking put forward a theory that suggests that black holes leak energy, meaning it was possible for radiation to pass through them. If we link this to the existing theories we have highlighted so far, it could lead us to the discovery of something revolutionary called time travel. Here is the drill. Researchers sometimes refer to white holes as wormholes. In this context, black holes and white holes are interconnected in a way that matter is able to go through black holes. As suggested by Stephen Hawking's theory, they could escape through white holes in another universe. Assuming this is true, scientists will be faced with another dilemma, which is finding where this other universe would be. You've probably heard of several theories predicting the existence of multiverses, but we're still a long way off from unraveling the mysteries around them. Right now, it's only a theory, but in reality, it's virtually impossible to navigate and escape a black hole. But if somehow scientists are able to pull this off, it would be the biggest scientific discovery of our lifetime.